If you do have any questions, I will definitely attempt to answer them at the end, or if I can't answer them, I will find you someone who can. So, welcome. Writing code is easy. Being a great developer is hard. So, as Amitai just introduced me, my name is Helen Scott, and I wanted to start with explaining why I wrote this talk. For those of you who joined the call a little bit early, you will have got a snippet of this story. So, I graduated over 20 years ago with a stereotypical computer science degree. And we did Java. So the university that I went to was quite forward thinking because Java was a baby back then. And when I graduated, I did what a bunch of my fellow graduates did. And I went and took a role as a Java developer because that's what you do. And I failed really badly at my first job. I failed so badly, I quit without another job to go to. And I even left the country in the end, actually. And I went to teach English abroad because I was absolutely convinced that I couldn't be a developer. And more recently, as I've been coming back to Java in my role as a Java developer advocate, I've been reflecting on why that was. Like, what happened? Was it just that I drank too much, or I didn't apply myself? Or for those of you on the call who remember it, I'm going to throw out client object request broker architecture. And yes, I was faced with that. And this time, relearning Java, picking it up again after all this time, it's much easier. And I'm trying to figure out why that is. So my hypothesis on this point is that learning code is the easy part. And it's all the other stuff that we have to learn on the job that's the hard part. So let me set the scene. Where do we learn? Primarily in three places. University, it's a very theoretical approach, normally spread over 3 to 4 years. It's the route I came through, so some of my stories will be relevant to that path. Bootcamp is another really popular approach. It's kind of a mix between theory and practical. It's normally a much shorter time frame as well, 1 to 3 months. Self-taught, right? This is amazing. If you are a self-taught developer out there, then my hat absolutely goes off to you. It's a very practical approach, and it is, of course, spread over however long you have or however long you give yourself. There's also apprenticeships, which I know are quite new. They're quite up and coming. If anybody has done an apprenticeship or even is offering apprenticeships, let me know, because I really want to learn more about that. Now, all of these have advantages. I came through the first route. So what topics do we cover when we learn this stuff? So I took a look at the syllabus for the 2021 intake of students for the same university that I went to. Now, caveat, because this is a US-based Java user group, this is a UK university, but I did have a quick look at some American universities before I joined the call just to check that we weren't miles apart, and unsurprisingly, we're not. Interestingly, it's not changed that much. There's a really heavy emphasis on programming, obviously, data structures and algorithms. Who doesn't love a bit of data structures and algorithms? Mathematics, very heavy in theory, compilers and architecture. I did amazing on that module. Human-computer interaction, that one's not changed. So I thought, well, what if that's just my university? So I went and looked at a bunch of other universities. They're the same. It's a very similar picture right across the world. There's things are called slightly different things, and other modules are thrown in, like computer music and data science and robotics. But fundamentally, they teach you how to write code. What about bootcamp? I started to see a little bit of a difference here. I started to see that practical element coming in. So I started to see things like working with GitHub, working with the CLI, modeling relational databases. I started seeing arguably real life tasks appearing on bootcamp syllabuses, which was quite heartening, actually. I thought, well, then what about self-taught? Now, this one's a really hard slide to create, because self-taught is as long as you take, and it's whatever courses you choose to do. I think the main advantage with self-taught is there's lots and lots of practical applications, because you have to, because you're doing it yourself. So you're going to have to get familiar with GitHub. You're going to have to work with databases. You probably, or you may have done a course with some ridiculous name like Learn Java in 5 days or something equally unrealistic. But fundamentally, they all focus on writing code. There were some interesting courses out there, but they were outliers. They were courses like Think Like a Developer, and I'm going to come on to that one. Life Balance, come on to that one as well. But fundamentally, they teach you this, they teach you how to write code. So that's what you learned and where you learned it. But what comes next? It's a real job. And I think it's really worth remembering from this point in that we are all self-taught. We go in, we have to teach ourselves this stuff. But this talk's called Writing Code is Easy and Being a Great Developer is Hard. So what is the hard? So the hard for me is self-taught skills that I'm going to take you through. These are the ones that I've learned in the last 20 years. Like Amitai said, I've been in many different roles and I've seen the inner workings of a number of different product life cycles and the people that created them, including myself. I'm going to take you through firstly what each skill is, why it matters, and then a bunch of resources that are relevant to that skill of where you can learn more. There's going to be blogs, there's going to be tweets, there's going to be videos. There will be a QR code at the end and I will paste the URL into the chat at the end as well, so you don't need to quickly write them down as we go, because I will furnish you with them all in one group. They're going to be relevant to you irrespective of your experience. So I'm going to start with the so-called easy stuff and move through the skills in the order that you might encounter them in your career. So if you've been developing for a while, you're going to recognize many of them, maybe all of them. And in that case, I really hope that you take a moment to recognize them as the independent self-taught skills that they are, and in turn help others who are fresh into their career. If it's within your remit, put some training in place to help them. And if you're still relatively junior in your career or you're still in that learning phase, that's great too. It's always better to know what's in store for you and to recognize that your learning journey is only just beginning. You can consider this a whirlwind tour of just some of the skills that you're going to acquire on your path to greatness. Okay, we're into the skills. Googling, right, that's a thing. Or professional plagiarism, as I call it. So this one's really interesting because at university, we are taught that all our solutions must be unique. They must be our own. We must not copy. We are taught that everything must be our own unique, beautiful ideas. And then we go into the real world and we have to completely flip that model on its head. If we don't use Google, people look at us weirdly. You have to know how to optimize your search. You have to know how to pick through the results and understand what's relevant. It comes down to how well you can relate to other people who are describing the problem and the technology. It's about how well you can think like everyone else. And of course, you all know the joke. What's the difference between a junior and a senior developer? Senior developers better at Googling. And if you don't think Googling is a skill in its own right, go and sit down with a less tech savvy person in your family and ask them to look up the opening times of the local store. And soon you will recognize this as a skill. So first resource for you on Googling, it is this blog from Joshua Hardwick, and he keeps it up to date. And you might think that a skill such as being able to find 2 words within a number of words of each other isn't that useful. But when you are down a development rabbit hole and Stack Overflow does not have the answer, stuff like this can be really useful for actually getting to the exact problem in the exact environment that you're experiencing. So it's not just being able to go to google.com and type your search in, it's about really being able to use Google. Okay, next one, reading code. We're taught to write code. We are not taught to read code. And furthermore, we are taught to write brand new code. And this is not the reality. We go out into the big wide world and we're never developing an app from scratch, or we're usually never developing an app from scratch. We are armed with a roll of sticky tape and prayers. And if we're going to apply that sticky tape, we have to be able to read the code, irrespective of who wrote it. So yes, your IDEs can help you here, but that's not really where I want to focus. It's about you. It's about learning to look for design patterns. It's about recognizing what the scope and the indentation can tell you. It's about recognizing that, and I do have a bee in my bonnet about this one, code does not tell you a story. Okay, technically with Java there is a start, but there's not really a start, middle, and an end. It is a huge conglomerate of a code base, and it's not some text-based dungeon crawl. So being able to read code is a skill in its own right. So I've got quite a few resources on this one, actually. First one is from my colleague, Trisha G. And she wrote this a while ago, but when I read it, it really stuck with me because she makes the very obvious, actually, statement that it's funny that computer languages are the only languages where one learns to write before one learns to read. How unbalanced is that? I mean, if anybody here is learning a second or third language and they're on Duolingo, and I don't know about you, but I can read Spanish a lot better than I can write it. It's a very interesting observation. So there's a bunch more resources and reading on that site for you. There's also a very interesting blog that I found from A&M Basler, and they wrote about some interesting techniques that you can use to improve your code reading skills, some helpful strategies for actually diving into that code base. You know, when you walk into a job, no one says to you, oh, you've got a month, just read the code base, get familiar with it. That doesn't happen. And they make the very interesting observation that to be able to write good code, you have to read a lot of good code. And this way you can learn how other developers think and how they solve a particular problem. Okay, next skill. Oh yeah, it's coming. So as we were discussing at the start, 1.2 was where it was at back in the early 2000s, and 17's coming, in case you hadn't realized. Pretty sure you will have. But it's not just knowing that 17 is coming, it's about having the conversations that are required around it, because it's not just your job to upgrade or not upgrade the code base. It's going to fall under most of our remits to put together a business case for why the business should or shouldn't upgrade. It's not just enough to say performance and security. We need to know what that looks like. And it's something else we're never really taught. We're never taught to ask why. We're never taught to question. But we actually really do need to do that in order to take full responsibility for the code that has yet to be written. So again, lots of interesting resources on this one. One from my colleague, Dalia, don't play video. Dalia Aboshisha, so she's an expert in this field. She's also written tools for upgrades and she's done talks as well. So there's lots of information that you can check out there. There's a blog and a video. Is the video going to play? Yes, it is. I thought it would. Another excellent resource from Angie Jones. She's somebody else who has covered this extensively. She has blogs and videos, and it's not just for test automation engineers either. So it's about skilling up on the language. It's about understanding what's new. It's about preparing. And this all falls into our remit that, you know, we're probably going to have to do this when we go out into the real world. Okay, next skill, technical interviews. Most of you on the call have probably had the unfortunate experience of a technical interview and wondered what was relevant in the technical interview to the job that you were potentially applying for. And even if you haven't had that experience, the chances are you will have that experience at some point. Technical interviews, you might be asked to implement something that is a little bit unusual and quite manual, and it may not even be within your day-to-day programming knowledge, which is why the system's broken. But again, there are lots of resources on this one. Trisha G has written about it from the point of view of, do you know how to actually remain a programmer and to avoid being promoted away from those positions? I think there's quite a few of us who have found ourselves quite senior in our career and realized that there's some kind of ceiling whereby the only way we can progress is if we want to go into line management. And lots of people don't want to do that, and that's perfectly fine. So again, there's some very interesting resources for you there. Emma Bostian is another one. She's actually written a book called Decoding the Technical Interview Process, and she has a video that can help you to ace your technical interview as well. So if you haven't had the joy of a technical interview, then definitely some resources there that can help you to get over that hurdle. Angie Jones, once again, has excellent articles for, on this, how you can ace your the ultimate test, as she puts it, ace your next technical interview. So they do exist. They're not fun, but it is worth skilling up on them so you can actually sail through one when you need to. If you're sat there and you don't think technical interviews are broken, if they're not broken at your place, great. They are broken in a lot of places. Then I would encourage you to read this blog from Sarah Kasabian. So she wrote this working for GitLab. I'm not sure she still works there, but she made some very interesting observations in that GitLab realized that their technical interview process was broken and it wasn't working for them and it wasn't working for the candidates. So she changed it to better reflect that. And there's some really interesting metrics in there about how you can modify your technical interview process so no one else has to go through that. If you're on the call and you think that the technical interview process where you work is broken and you have the power to change it, definitely check that blog out. Okay, yes, I know there are more IDEs than that, but the meme did not allow it. At some point in your career, you're going to have to start making decisions on your code base, and you're going to have to start making decisions about your tools. You may be fortunate enough to go into a role and be given the choice of which IDE you want to use, and you can pick the one that works for you. You're going to have to choose a library. You're going to have to choose a framework. And as I've already said, net new code's pretty rare. Modifying an existing code with our roll of sticky tape is far more common. So we have to rely extensively on these third-party libraries and these frameworks, and they all need management as well. There's so many decisions to be made. I don't have a resource on choosing an IDE, by the way. That's up to you. What I did come across was this really interesting blog from Kyla Matthews, and it's choosing the right Java library. And when I read the list of questions, I thought, oh, it's all kind of obvious, really, isn't it? But it's like, it's the only obvious when you know how, when you've thought about it. So I think these are really good prompts for us. So do you like the API? What are your needs? Do you actually understand what your needs are? How popular is it? I don't think anyone pays for ratings for Java libraries. It's not Amazon, but it's worth checking out. What's the testing status? Are there any CVEs? There's also the side of things of getting familiar with managing your dependencies and knowing what your upgrade strategy is. I have had the misfortune to see Scrum teams brought to a shuddering halt because of upgrades to their dependencies, and not just for one sprint, for multiple sprints, because this has kind of caught them by surprise. So we need to factor this in. And again, this is stuff that we kind of find out the hard way often after it's burned us once. All right, next one. Bad news. You don't get to choose your team, a bit like your family, and you're no longer the lone wolf you might have been at university, and it's really, really hard. And I did not have a full appreciation of how hard this is until really probably only maybe five years ago. This really dawned on me on just how unbelievably hard it is to really be part of a fully functioning, high-performing team. It's incredibly hard. I experienced this firsthand, mostly doing technical writing, because I'd often be the only person that was working across the different Scrum teams. And I'd be the only person in development doing this. All the Scrum teams would be relatively isolated, all working towards this big release, but I would be pulling it all together to package it up and present it to the customer. And the last person a developer wants to see 2 days before the release is me, is the technical writer. So you really have to get to know them. Like, what's their name, obviously? What are their hobbies? What are their partners' names? Their kids, their fur kids? What drives them? What stresses them? Do they like a formal meeting, or can you just stroll up to their desk? Back in the days when we could do that. It's really about understanding what makes them tick, so you can work alongside them and really, really gel. And it takes, like I said, it takes an awful lot of effort. It's the old adage to go somewhere quickly, go alone. If you want to go far, go with your team. It's about being able to communicate. A couple of resources here. This is a really interesting blog from Offer Vogman, and they talk about how technical skills are only part of the story and how teamwork matters. So give some really interesting tips when you read the blog about leaving your ego at the threshold, embracing feedback, being accountable. Don't be a knowledge hoarder. All that happens if you're a knowledge hoarder is people come to your desk or phone you more and more and more as they try to get closer and extract that information and grow their understanding. Also a blog from Alison Denisco. So they talk about 10 ways to become a better developer. And it's things like psychological safety, which has thankfully really blossomed into a hot topic in the last few years. Encouraging equal participation, how you can assign credit, amplifying unheard voices in meetings. So repeating like what's been said and letting people who don't normally speak have the floor. Holding yourself and others accountable, maintaining a growth mindset. And that is something that I think is incredibly important for a whole bunch of reasons, because if we don't have a growth mindset, it's very easy to shut ourselves down. It's very easy to say, well, actually, I can't do it, rather than say, I can't do it yet. And that's the difference between a fixed and a growth mindset, is the yet. Okay, next skill, solving problems. Oh, we've all been here, haven't we? So there's two strands to this for me. There's the first one is it's about keeping it simple. It's about the acronym, keeping it simple, stupid. We all want to impress. We all want to please the team, please the boss, deliver, show what we can do. But our work blossoms with complexity, as everybody on this call knows, incredibly quickly, like insanely quickly. So we have to rein ourselves in. Then there's also, as per the meme, it doesn't work. Why? And I'm definitely in the second category. It works, not really sure why. It's about getting in the right place and not beating yourself up when you find yourself in this spot, because it's a really hard spot to be in, and it can be quite an isolating spot to be in as well. So I went looking for resources to understand this one a little bit more, and how we could actually get better at it, I suppose, of being in this problem-solving state. And I came across a great resource by Richard Rees, and what they say is, this is what we humans do when we have a problem. We try a solution, and if that doesn't work, we try another one. And if that doesn't work, we repeat step 2 until we luck out. And that's what we do. We effectively, if you think about an attack vector, we brute force. That's what we do. And it's the worst way to solve a problem, and it's a big waste of time. So what the author proposes is, instead of doing that, wrap a framework around your problem. So the framework has 4 steps. First one, understand. Really understand your problem space. Know what you're dealing with. The second one is plan. Don't dive straight in. Sit back and plan it. Love a good list. Divide it. We've all heard the phrase divide and conquer, right? This is just divide, but in a framework. You will cry. Definitely been there as well. 4th step, are you stuck? Probably, if you haven't managed to solve it at step 3. So what do you do then? Well, you can debug, you can reassess, you can research, you can go round the loop again, but this is far more efficient than trying to brute force solve a problem. Okay, this is the only annoying GIF in the whole presentation, but I'll pause it in a minute. Oh, this is also a self-owned slide as well. I didn't write any tests. I'm going to pause it now. I didn't write any tests at university. That's clearly not a good thing. Now, relearning Java and coming back to this journey, test-driven development is now very much a thing. It was a thing in the late 90s. I think Kent Beck pushed it back into the spotlight in the early 2000s. And it's, for all good reasons, been growing in popularity ever since. But most of us don't have a test-first focus, and tests are still sometimes the poorer cousin in a lot of the work that we do, and we're rarely taught to write them. And obviously there's plenty of great Java testing frameworks out there, JUnit, Mockito, Spock. It's about understanding the value of the tests and what those tests give you. So what those tests give you in terms of confidence for your code. Resource-wise, Kent Beck's book is brilliant. Not much more to say about that. It's very good. I also found this blog from Dave Cheney, and they make a very interesting observation of, even if you don't, someone will test your software. And I really like that. And it's slightly passive aggressive and threatening, but it's absolutely true. So Dave goes on to talk about who should perform that testing, what proportion of it should be manual testing, what those tests mean for your main branch, and of course, how they can give you confidence to change your code. Oh, it's another cell phone slide. So I put Git there because I think most of us will either professionally or personally be working with Git at some point. So my version back in the day of source control was zipping up code and putting it on the desktop. Yep, that happened. But we have to become proficient with version control systems, and we do this very, very quickly, right? We very quickly learn how to clone the repo, make a branch, do a commit, push, little merge, update. We learn what we have to do very, very quickly. But there will come a day where things go wrong. And you will forget to make a branch, and then you will do some commits, and then you'll do a few more commits, and then you'll realize they should have been on the branch. Then you'll make a branch, do some commits, then you'll try and go back to another one, and you'll try and cherry pick it or shelve it, and the IDE will give you an error. And in the end, you're going to phone the resident Git expert, and every team has one. And one of the teams that I used to work in previously, it was a gentleman called Paul. And Paul, in the end, did a very well attended lunch and learn for the whole of engineering on all the innovative ways that Helen had messed up Git. And I learned two things from that. One, I'm amazing at messing up Git. And secondly, other people wanted to learn. Other people wanted the mental model and the knowledge that Paul had on how to get themselves out of trouble when things had spiraled a little bit. So I would really encourage you that if you're not already the Paul in your organization, be the Paul, because it is incredibly useful to be able to get yourself out of trouble by really understanding what's going on. If you are not yet the Paul, this is an excellent resource. It's a book by Katie Seiler Miller. It's called Oh Shit Git or Dang It Git. I don't think Americans swear as much as Brits, so I'm going to stick with dang it. It actually goes from the problem point of, I accidentally committed to the wrong branch, or I need to undo a commit from like 5 commits ago. So I really like that, and I learned a lot from going through that. This is another amazing website. It's maintained by a gentleman called Peter Cottle, and it is a really nice visual representation of the mental model of Git. So again, we've got the basics, but it's about the advanced stuff and understanding what's going on so we can get ourselves out of trouble when we need to. If you are just starting out in your career, and I've heard, and I myself have confused many times, Git and GitHub and Git versus GitHub. There is an amazing blog by Aisha Ruat, and she takes you through the differences between them, and it really starts basic and builds up. So if you're not too sure, definitely check that out, because you need to know the difference between them. Okay, next one, reviewing code. No one ever teaches us this either, right? We write code and then we give it to our lecturer and they mark the code and that's it. No one ever says, oh, could you review Joe's code over there? It's really hard and no one teaches us how to do it. And if we're not taught how to do it, it can become toxic. And I will come on to that with some of the resources. It's very easy to say, oh, your method name doesn't follow convention, or why have you used that loop construct when you could use this one? But experience and the company's own guidance will tell you what to focus on and what to give feedback on. Resources wise, Angie Jones, again, so I loved this article. It is 10 commandments for code reviews. and I'm going to paraphrase it down because you should definitely just go read it. But it's talking about how not to take things personally and how you can detach yourself from the code. How you can look at the feedback without feeling like it's some kind of personal assault on your skills, how you can be rational about that, how you can compromise on the solutions. It's a two-way thing. And of course, how treating others how you'd like to be treated. So definitely check that out. There's also some resources from Dr. Michaela Grilla, and she makes the observation that I think most of us have probably been in at one point or another, whereby code reviews are reducing code velocity and they are being thought of, I can't judge, but they are being thought of as meaningless. And at that point, when they're slowing, or they are being perceived to slow the team down and they are perceived to be meaningless, what's the point in doing them? So she's got some very interesting research and actually talks about what you can do for a code review, what a code review should and shouldn't include. And of course, this is all going to be different on a per company basis. But if code reviews are a problem or are a challenge, then this is definitely something to check out. All right, next skill, debugging. So when I first gave this talk, I made a statement such as, I started out debugging with sysout statements, and someone put in the chat, we all still debug with sysout statements. So it's not very efficient and it's not very fast. And like I said, IDEs weren't really around when I learned to code. IDEs are now, and they have built-in debuggers. They're obviously incredibly valuable. I would encourage you to try and learn the functionality in your debugger before you need it in anger, because it'll be much easier and kinder on you from a journey point of view. But I want to talk more about the mental aspect of debugging code, because it's really hard. And it's another one of those skills where it's like, we have this skill, but where's the resource for it? How do we learn this? And fortunately, I realized that I follow an amazing woman on Twitter called Julia Evans. Definitely check her work out. She put a very timely tweet, which was brilliant for me, about why is it, if we've run into a bug, why is it impossible? What's happening? Because she like me, really wanted to understand what makes us feel that way, because it's debugging for most of us isn't particularly fun, especially if we've been doing it a while. It's hard and it's mentally draining, and it can leave you feeling quite vulnerable. Now the summary, and I believe she's now produced design on this as well, is the bug might be hard to reproduce. Your mental model might be missing something, or you don't have the tools to inspect the program state. That comes back to the debugger. One of your assumptions might be wrong, or the bug might just be really blooming complex. So definitely check her Twitter out, because it's not, she's got loads of amazing designs that are really informative. Oh, this is my favorite skill. Estimating stories. No one teaches this either, right? You get told that your assignment is due in 3 weeks, and you calculate back because you're a youth and you're young, and you're like, well, I can do this other stuff for 2.5 weeks, and then for my final half a week, I'll do my assignment. That's how it works. It's a very linear progression. And we're not asked, no lecturer or professor ever gives us an assignment and says, so Helen, how long do you think that will take you? Right? That never happened. And then you walk into your real job and you're under business pressure, and someone says about a code base that you don't fully understand, because you never do, how long is that going to take? And you have no idea. See, I rant about this one. It's about looking at the history, and it's about using good judgment. And it is, of course, learning from mistakes. But I really wanted to understand why I struggled so much. And I found the perfect analogy. And it's this blog from Bostian. So imagine the scenario. You're going to be sent to the shops for supplies for a camping trip. 6 to 10 people. The trip will last 3 to 5 days. Everybody eats different food. Buy some drinks, not too many. Don't forget the tea. I think that's why I like this analogy, being British. Don't forget the tea. Get the best possible quality. And now before you go into that store, tell me how much it's going to cost. This is why story estimation is so hard. You have no idea, it's really hard. So the blog does go on to talk about some strategies to deal with this. Again, they're obvious when you see them written down, but we have to sometimes take a step back and ask ourselves the questions. So breaking down the work, not making assumptions, taking our degree of confidence into account. We've all been in the room where one person said 20 and the rest of the room have said 3. There's one really important point as well that's towards the end of this, and it's about don't forget about the things we tend to forget about. So just remember that one. Now, again, I had a little bit of feedback on this talk of when somebody saw this slide, they said, well, what about project management? Because that also falls under a developer remit. We have to manage our own time. A lot of us sit in a room and we plan a sprint, but then we have to actually manage that time and all the other asks that are made of us. And that's really hard as well. And it's not something that comes naturally to many of us. There's another great resource here by Maddie Osman. Why software developers suck at estimating time and how to fix it. So she talks about Parkinson's law. That is the law that everything will take as long as you give it. You estimate it at a day, it will take a day. Again, obvious, but we always forget it. Everyone is different. Everybody's different, thankfully. Software development is a process, and you have to dig into this one a little bit more because it's not just about writing the code, which hopefully you're up to speed with. And it takes time to get into the zone. And that goes back to what I was saying before of don't forget the things that we tend to forget about. It takes us time to get into that place. It always takes us time. We're not robots. All right, next skill. I'm going to say it again. We are taught to write code, and then we are taught to tie a little ribbon around it, pop it on a pedestal, and admire it. We're not really taught to delete code. You don't go around deleting your assignments. Most of you don't anyway. And we're not really taught that code has a life cycle, or to think about upgrading, going back to Java 17 coming. So yes, it's another place where on a practical perspective, your IDE can help you, but it's more than that. It's about the mental model of deleting code. So when I was looking for resources for this one, I came across a really it's a really great blog, but I think it's a blog that might make some people's blood pressure rise slightly. And it's by Melissa McEwen, and she makes a very confrontational statement of, I'll delete your commented out code without reading it, and I'm not sorry. And that's a statement clearly designed to get your attention and to get you thinking, because what the author's point was that's what version control is for. If you've got code in your code base that's commented out and no one really knows why, that in itself is quite a scary problem. So they do go on to talk about how you can catch this before it becomes comment junk. For example, you can uncomment it, see what happens. You can turn it off if it's a configuration. It's ultimately, if the person who's potentially commented it out is still there, you can ask them, but it's potentially not a good situation to be getting into if you've got commented out code in your code base. If you think it is a great situation to get into, it's a bit of an older article, this one, but it's a great read. Summary of which, New York Stock Exchange system, they manually upgraded their servers. One of those deployments failed, left the old version running. They didn't know about it. Simultaneously, they'd recycled an old flag to mean something completely different because it wasn't deleted from the code base. It went live and zombie apocalypse. It resulted in a loss of $10 million per minute, and the system was live for about 45 minutes. So if you like scaring yourself about deleted code, then that's a great article. Right, pair and mob programming. I had to tell the meme maker to use lowercase for this one because it was so offensive. So Pair programming it's a really powerful technique. I've only recently started doing it, and I am quite honestly blown away by what it can do for me, and the way that I can learn and grow with it, because two heads really are better than one. Mob programming as well, similar and not similar, derivative of. It is mentally exhausting and incredibly rewarding, all in one bundle. One of the really cool things that I like about pair programming is sitting next to somebody who's using the same tools as you, because you get to see all their shortcuts, you get to see how they move around their environment. You learn loads, you really, really do. So first resource on this one is from Sam Fair. So Sam has written from the point of view of doing mob programming for about 5 months. Programming mobs are not disorganized, not prone to rash decisions, angry and unwilling to compromise, you hope. So that's a really interesting read, especially if you're thinking about doing mob programming or introducing it into your organization. It's quite an interesting viewpoint. There's also a blog, we actually included this in Java Annotated Monthly a couple of months ago, because we all read it and went, yep. And it's a blog from Nat Bennett, who was part of an experiment from 2014 to 2020, paired for about 8 hours a day for years, not months, years. And he did that along with hundreds of other engineers. And he makes this interesting observation. It's one of the best things I've ever done for myself, socially and emotionally. And it produced some great software, but it also burned me out. And I really like that from the point of view of looking at it from the other side. It wasn't all bad. I would definitely encourage you to read that blog, because it's got an awful lot of insight into it. If you're sat there and you haven't done pair or mob program before and you have no idea what I'm talking about, there were some guest authors on Martin Fowler's blog, Brigitta Boccola and Nina Sisega, and they really do start at the beginning. So how to do it, what the benefits are, what the challenges are, red, green refactor, everything kind of from the basics and works through. So if you haven't done it, you don't know what it is, and you want to try it, have a read of that. Who doesn't love a meeting? So I saw a post on LinkedIn not long ago from a gentleman who he was really enthusiastic about the number of meetings that he had in that day, and he associated that statement with being busy. And I could not get over myself, because I was just like, well, you can't be busy, you're in all these meetings. And it really drove home to me just how little code we get done when we're in meetings. And it's worse than that. It's the heavy context switching cost when we're in meetings. Again, when we're learning, it's very linear. We do one thing, we deliver, we do another thing, we deliver, so on and so forth. But it's really about learning to use your time wisely, whatever that looks like, because there's not a single person on this call, I expect, that actually goes, yay, I've got 6 meetings today. You've probably all heard of the Eisenhower matrix, urgent versus important, but how often do you actually sit down and look at that matrix from the point of view of your workload? So if it's urgent and important, get it done. If it's urgent but it's not important, give it to someone else. If it's not urgent but it is important, plan it. And if it's in the bottom quadrant, what's it even doing on your plate? Just get rid of it. And it's worth going through that with your the work that's on your plate every now and again, because it can really help to clarify and get you out of a hole if you think you've got too much on your plate. You may still have too much on your plate, but it will help. This is a great blog from Dan Lyons. He actually writes in this blog, it's the law. Software engineers have to hate meetings. If you're caught enjoying yourself in a meeting, you get your dev card pulled. Now, what Dan Lyons did was he went out and he spoke to developers about, did they really dislike meetings, or was it something else? And the answers are there. That's what we don't like. It's not necessarily meetings, it's that stuff. It's inefficiency, it's poorly planned, it's poorly executed. So there's lots of help as well in that blog. So one of the really interesting things I like doing, and I wish I'd done, in fact, I might do it just soon, is take an inventory and establish the baseline of your meetings for the month. So your sprint planning, your stand-ups, your retrospective, your review, your product owner meetings, your whatever you've got, what are the meetings? And then add in the ad hoc meetings, all the time the product owner wants to speak to you. And then assess the value of each of those meetings. Group the meetings if that works for you, but I'm going to come on to that because that's a bit of a double-edged sword. Switching contexts, another skill. This can be planned. So for example, in the sprint, it goes back to what I was saying about don't forget about the things we always forget about. So it's about factoring this into your estimates. Most of us can't just put down one job and start another job. It is also about the unplanned stuff. So the life curveballs, and there's been a lot of those lately. It's about remembering to factor in the cost. So there's a very interesting blog here from Mayumi Nishimoto. Now the blog talks about something called attention residue, and this was a completely new concept to me. It's where our brains cannot switch off. So when we do that thing of grouping meetings, like from 9 in the morning to 1, and we get to 1 and we're still thinking about the meeting that finished at 10 a.m. and that's attention residue. And it's about how our brains are simply not designed to work on 2 mentally challenging tasks at once. They're just not designed to do it. And I used to think I was amazing at this, but turns out I suck at it. It's about how we can actually have the engagement and satisfaction and not be left completely exhausted. So the blog talks about regular deep work, understanding how we switch context, because we all do that differently. Some of us need to go for a walk, make a tea, have an interaction with another human being. How we want to time box our schedule. One of the pieces of advice is to use anti-distraction apps, which I think is really meta because that's just another app on my phone to bully me. So attention residue is a really interesting thing to read up about. Love Grumpy Cat. We get it. You don't want to annoy your boss. You don't want to let the team down. You do want to progress your career. But a lot of the times we just have to say no because burnout's real. If we don't set boundaries, other people will invade them. And it goes back to setting priorities as well. It is one of the hardest things to do. A couple of resources here. Hussein Pollitt-Urich. They made a very interesting observation that all these bullets here are about your code. And we could say no to writing the code, which kind of blew my mind when I first read it, because I thought, well, we're developers. You don't say no to writing code. But actually, we can say no to writing code, because here's a really good reason to push back. How valuable is that code? Because it's going to need to be read and understood, tested and debugged. It's going to increase defects, might introduce bugs. There's also how do we say no? So Danila Petrova wrote this, that we've often felt the pressure to carry out the tasks in our workday. She talks about why you need to start saying no, when you need to start saying no, and perhaps most importantly, how we can say no, because I am terrible at saying no. I'm still learning this, and it's really, really hard, and it's hard to do without accidentally saying yes. At least that's my experience of saying no anyway. All right, coming towards the end, being aware of your mental health. It is a fast-moving industry, and like any job, it can take a detrimental toll on your mental health. It's about the importance of mindfulness, rest, having those around you. It's about your support network, which right now for many of us is in tatters by the side of the road. And we have to find that, and we have to pick it up. It's about taking time off, recognizing when you're on that path to burnout, because many of us have learned that the hard way. I do also want to say, if there's any more junior developers on the call, you don't need a side project or to hustle to be a great developer, and you don't need to code on your weekends. If that's what you want to do, great, do it, but you don't need to. Lena Kozar and Vova Vok talk about mental health in software teams. So they talk about focused and unfocused modes. Not forgetting to work out. Teamwork, like I've already spoken about, it's hard, but it is everything. And get your happy hormone, because that will really go a long way to improving and helping your mental health. Two great articles that were published in Forbes as well by Brian Robinson. These are not developer specific, but they really are, I really identified with them. And I thought, well, if these statistics are true for non-developers, I bet they're true, if not even higher, for developers. The second one, if there's anybody on the call who is currently working remotely and the business that they work for has proposed a hybrid approach to going back to work, so part in office and part at home if you want to, have a read of the second blog, because it calls out some red flags of organizations that are not completely invested in remote working. So things like there are no senior leaders who work remotely, or celebration and praise only happens in the office. So if you're in that situation, have a read of the second one. Right, last skill you need to have is a great work-life balance. And it is so, so important. Your family, your friends, your hobbies, especially as for most of us, we can't readily meet these people right now. There's various situations all over the world, various lockdowns, various states of vaccination. Whatever you can do to have that great work-life balance and keep in touch with those people, do it. It's really important. Work-life balance tips for programmers. I think they probably work for anyone, but I liked the list. It's about prioritization, routine, get rid of the crap that doesn't matter. Don't be a perfectionist. It is the enemy of getting anything done. Learning to say no, like we've already spoken about. Enjoying yourself. Don't play video. Right, final blog from Karina. And she talks about the things that you can do. So prioritization, accepting that you can't know everything, improving your efficiency, creating time, which is a concept that is a little bit weird to wrap your head around. There's a TED video it might be a TEDx video at the end of this, this blog that I would encourage you all to have a look at. It's not long. It's just about one small change that Nigel Marsh did and the effect that it had on his kid. The changes don't need to be big. They don't need to be massive to have a better work-life balance. They can be so, so small. So to summarize then, writing code is easy compared to all the other skills that we're taught and we have to learn when we go out into the real world. What do you do now? The QR code and link are going to be on the next page, but I'll also drop them into the chat as well. But this is the part where you give yourself a huge pat on the back for being generally rather awesome and hopefully realizing just how far you've come and you've organically learned these skills as you've gone along. It's also the part where, if you can, you help someone else who's new to the industry. I'm particularly passionate about this part because of my specific journey. These people might not have these skills yet. And if you do, then this is the part where you can show them the way. And that's the QR code and that's the link, but I will also drop them into the chat in a moment.